Hello, this is the Bird Nest project, presented to you by Claude, Eric, and Mike. The goal of this project is to find the bird nest efficiently, in order to help ecologists to spend less time finding the bird nest and more time studying and helping the birds. As we know, bird nests are quite hidden to protect the young birds from predators, so it is very difficult to find them directly. What we want to do is to exclude the areas where it is impossible to have bird nests, and to identify the area with high potential, so that the ecologists only need to pay attention to the areas where bird nests are more likely to be found. We want to use a computer vision approach to identify the high priority areas. So we need images. We'll have access to many images generated by different cameras mounted on a quadcopter, which can scan the landscape quickly. We have near IR images, which can detect the plants. We have thermal images, which can detect heat difference in the environment. And we have visible light images, which has the highest resolution. So far, we processed the near-infrared images and the visible light images. Now let's take a look at what we did with each type of images. The image on the left is an image that has its red value in RGB replaced by near-infrared. And based on that value, we could calculate the normalized differential vegetation index, NDVI, which measures how healthy plants are. With the NDVI, we can tell what material are living and what are dead. So, if you look at the image on the right, which we did a threshold on the NDVI, and found what material are living and what is dead. Of course, in a bird's habitat, half of the material, such as grass and trees, will show up as positive, indicated by the white pixel on the picture. And the other half, materials such as rocks, soil, and water, will show up as negative. Intuitively, visible light images give us the least information on bird nests, because bird nests are hidden from view. However, we can find the trees where birds build their nests. Since visible light images have the highest resolution among all the different images we have, we decided to do classification on visible light images. In a nutshell, classification takes an image and identifies which part of the image belongs to which of the classes. The algorithm should magically label leaves in the image as leaves, grass as grass, and so on and so forth. Based on our current progress, we can exclude up to 89% of the area by classifying. Now let's explain to you how the magic works. In the future, we would like to process the thermal images, which can detect animals in the image using the temperature difference. After we have the 3 layers of information, near IR, visible light, and thermal images, then we can combine them to enhance our result. Finally, we want to find an efficient path for the ecologists to visit all the high priority areas. To summarize, we're doing a lot of image processing in order to reduce the search area of where bird nests can be. This will help ecologists find bird nests more efficiently, so that they can spend less time trying to find the bird nest and more time studying and helping the bird.